Hey everyone, thank you for joining. This session is called From Rising RU Cost to Stable Performance, a practical Cosmos DB case study. What I'll walk you through today is realistic scenario where a Cosmos DB workload started showing performance issues as it is scaled. We'll look at how RU consumption increased, how throttling and latency appeared, and more importantly, how we diagnosed it and fixed those issues. The key idea behind the session is simple. Design decisions in Cosmos DB directly impact cost, performance, and scalability. So rather than focusing on scaling first, we'll focus on understanding and fixing the design. Let's get started. So before we get into technical details, a quick introduction. I'm working as a cloud engineer, primarily focused on building and managing solutions on Microsoft Azure. My experience involves handling production scale workload where performance, reliability, and cost optimization is critical. I've also had the opportunity to speak at community events like Hashi Talks India, Global Azure Pune. I'm also Microsoft certified Azure administrator. The context here is important. What I'll be sharing in this session comes from real world experience working with production systems, not just theory. So, quickly walking through the agenda, we'll start with the workload and problem context. Then we'll look at issues we observe, mainly RU spike, throttling, and latency. After that, we'll go into root cause analysis using matrices and insight. Then I'll walk you through the designs changes we made. And finally, we'll look at the result and key takeaways. So let me first walk you through the system we are working with. This is a Cosmos DB account with a single container called user activity, storing events like login, clicks, and page views. The setup is fairly standard, deployed in central India with 4000 RU per second provision throughput. The partition key used here is user ID, which at first seems like a logical choice. In terms of workload, we have around 241 regular users, along with one automated integration account continuously generates event. So this details becomes important later because it directly impacts how load is distributed across partitions. So this is where the issue first surfaced. We received an alert indicating that normalized RU consumption had crossed 90%. At this point, the typical reaction is to increase throughput. But increasing RU doesn't solve the underlying problem, it only delays it. So instead of scaling immediately, we decided to analyze the matrices and understand what was actually causing the issue. So let's start with the RU consumption, which is the most important metric in Cosmos DB. At baseline, the system is using around 20% of available RU, but we see sudden spike that reach 100%. Were 8 saturation events in just 30 minutes. The average RU usage is already high at around 64%, and during spikes, it hits full capacity, which triggers throttling. The key observation here is the pattern. This is not a steady increase, it's burst driven. That tells us the issue is not constant load, but something specific causing these spikes. Now, let's look at throttling, specifically HTTP 429 errors. We observed 142 throttled requests in just 30 minutes. These occur when RU reaches 100% and Cosmos DB starts rejecting requests. But the important part is what happens next. The SDK automatically retires these requests up to 9 times by default. So these 142 errors actually resulted in thoroughly 7,000 operations, and all of those retries still consume RU even though they fail. So instead of helping retries, actually amplify the problem. So this is what we call retry amplification. Now looking at latency, so P99 latency reached 284 milliseconds, which is about 28 times higher than expected SLA. So even the median latency increased to around 98 milliseconds during peak periods. If you compare this with the RU chart, so you'll notice that latency spike happen at the same time as RU saturation. So this tells us that latency is not an independent issue. It is directly caused by throttling and the read-write behavior we saw earlier. So now, this is the root cause. One partition user is consuming over 81% of total RU, and the remaining 241 users are sharing less than 20%. So, this user is an automated integration account generating a high value of events. Cosmos DB distributes throughput evenly across partitions. So if most traffic goes to one partition, that partition becomes the bottleneck. So even if total RU is available, it cannot be used effectively because it is concentrated on a single partition. So now, putting everything together, we have identified three compounding design issues. First, the partition key caused uneven distribution, leading to a hot partition. Second, queries were running across partitions, which significantly increased RU consumption, in some cases, 100 to 250 times more. Third, the default indexing policy was indexing all fields, which increased write cost by 2 to 4 times. So these issues don't exist independently, they amplify each other. And most importantly, none of them are solved by simply increasing RU. So this is a design problem, not a capacity problem. So starting with the most impactful fix, partition key redesign. So earlier we were using user ID as a partition key, so which caused all traffic for high volume user to hit a single partition. We changed this to a composite key by adding a time component using a format like user ID and year and month. So this allowed the workload for that user to be distributed across multiple partitions instead of one. So as a result, the load on a single key dropped from over 80% to under 5%, effectively eliminating the hot partition. One important thing to note is that changing the partition key requires rebuilding the container. So this needs to be planned carefully. Next is we optimize the query patterns. Earlier queries were running across partitions because they didn't include the partition key. This resulted in very high RU consumption. In some cases, between 180 to 400 RU per query. After optimization, we added partition key filter to target specific partitions. So this reduced the query cost significantly down to around 2 to 4 RU. So in cases where both the document ID and partition key were known, we used points to reads, which cost around 1 RU. This change alone had a major impact on both performance and RU efficiency. Next, we looked at indexing. By default, Cosmos DB indexes all fields, which increases write cost significantly. In our case, this resulted into 2 to 4 times higher RU consumption for writes only. So we optimized this by indexing only the field required for queries and excluding large or unused fields. We also added composite indexes for query pattern that required sorting. This resulted in approximately 60% reduction in write RU along with improved write performance. Now let's look at RU consumption after the optimizations. Instead of spikes, we are now see a stable pattern with usage staying between roughly 20 to 35%. The maximum RU usage is around 34% and the average is about 27%. So most importantly, there are no throttle requests. This tells us the system is no longer hitting capacity limit. The key observation here is that the workload is now balanced and resources are being used efficiently without any sudden burst or saturation. Now, looking at throttling after the optimization, we no longer see any HTTP 429 errors. Since RU usage is stable and within limits, requests are processed successfully without being rejected. This also means there is no retry amplification anymore, and we are no longer wasting RU on failed retries. As a result, the system behaves much more predictably and efficiently under load. Now, looking at latency after the optimizations, P99 latency has dropped to around 60 milliseconds, which is within an acceptable SLA range. We no longer see sudden spikes and response times are consistent. Earlier, latency was directly correlated with RU saturation and retries. Now that those issues are resolved, latency remains stable. This is a strong indicator that system is operating within its capacity and performing efficiently. Finally, looking at partition distribution after the changes, we no longer have a dominant partition. Each partition now contributes less than 5% of total RU. The workload is evenly distributed and there are no hotspots. This means all partitions are being utilized effectively and throughput is no longer wasted. This is how Cosmos DB is designed to scale with balanced distribution across the multi partitions. Looking at the final results, so the workload remained the same. We did not increase throughput, it stayed at 4000 RU. RU usage dropped from full saturation to around 34%. Throttling went from 142 errors to 0. P99 latency improved from 284 milliseconds to around 16 milliseconds, and partition distribution became balanced with no single partition dominating. The overall outcome is stable system with efficient resource usage. Same workload but completely different results due to design changes. So, to summarize the key takeaways, partition key design plays a critical role in how well Cosmos DB scales. In many cases, RU related issues are actually distribution problems rather than capacity issues. Cross partition query can significantly increase RU consumption if not handled properly, and default indexing can introduce unnecessary overhead if not optimized. The main point is focus on fixing design before increasing throughput. When you face RU related issues, so this is a simple approach you can follow. First, check the RU pattern when it is steady or spiky. Then look at the 429 rate to understand throttling impact. Next, analyze the partition distribution to identify any hotspots. After that, review queries that consume high RU, and finally, validate your indexing policy. This structured approach helps you identify the root cause before making scaling decisions. To close, I'll leave you with a few simple actions. Start by checking your partition distribution. This is often where the real issue is. Then identify queries that are consuming high RU and review your indexing policy to remove unnecessary overhead. The key takeaway from the session is simple: design first, scale later. Most performance issues in Cosmos DB are not capacity problems, they are design problems. Thank you for your time.